Okay, good evening, everyone. We're about to start, so welcome at the CocoaHeads at Q42 in The Hague today. And Marco is going to start the slides, probably. So as you might know, we are part of the international CocoaHeads.org, where we organize a monthly meetup for iOS developers, or basically Apple developers, anything Apple related. And we get hosted by different companies. Today we're at Q42 in Den Haag. We have a few sponsors that help us run our daily costs, let's say, and keep everything going, for which we would like to thank them. You can see them right here. And of course, there's a shop where you can buy all kinds of apparel, t-shirts and everything. Looking at Mathijs? No. So the agenda for today is Mathijs Brenson about frameworks, libraries and packages demystified, and Mathijs Kadijk about the Mac-tastic adventure, indie adventure. And that's basically it. So before I'm going to give the mic over to Mathijs, basically, if you want to do a talk, come and find us or contact us via mail or appropriate channels. And in case you want to see the movies, you can watch them actually in our TV app or back on YouTube. And the next time is going to be the 18th of October at the NOS in Hilversum, if you want to join us. So the meetup is already there in order to sign up and see the meetup page. A friendly reminder for the newsletter and any other links you might want. And then I'm going to hand over the mic to Mathijs for his first talk. You don't actually need this, I think. So
nope.
Have fun and thank you, Mathijs.
Thanks. Thanks. Welcome, everybody. So a little bit about Q42 first. We're here in The Hague. Q42 also has an office in Amsterdam. And we are in total about 85 nerds who work on websites, backends, mobile applications for both Android and iOS. We do a lot of native mobile development, but also some React Native, some Flutter development, etc. If you want to know more about Q42, you can find us at q42.com. On to my talk. So I'm going to tell you some things today about frameworks and libraries on Apple platforms. So why did I come up with this topic? So last year I was doing a project for a client at Q42. And this client was a building construction firm. And they have all these 3D models of buildings. And they wanted to visualize them in augmented reality on the iPad and iPhone, basically. So they're working in this architectural software called Autodesk Revit. And it spits out a certain file format. It can export these building models to something called an IFC file. And that's what I needed to open in my app and display it in ARKit, basically, and in SceneKit. I could do that myself, so parse that file format, but it was complicated and I needed some C++ libraries. There already existed a bunch of open source libraries for working with this file format and for working with 3D geometries, etc. So I wanted to use them, but they were cross-platform libraries. They would run on macOS, on Windows, on Linux, but not on iOS specifically. And hence I needed to learn a bunch of things to get it up and running. Yeah, so for this all still context for what I'm working up to, but we have this IFC file that the architects give us. The app needs to open it and convert it into some form of 3D geometry. And then we load it into SceneKit and ARKit. And this part is where the libraries come in. So I found something called IFC++ and Open Cascade, which did just what I needed. But compiling these on my poor Intel Mac took like 30 minutes. So I needed to package them up somehow into binaries so I could ship them with my app, because I had to pre-compile them, because waiting 30 minutes every time you need to do a clean build is no fun at all. And the app architecture I ended up with looks like this. So we have our app, which is written in Swift, and it uses a Swift package that I wrote myself called IFCKit, I dubbed it that. And that needed to interface with the C++ libraries. As you can see, the libraries, they are written in C++, and my Swift package is written in something called Objective-C++. So that's actually Objective-C that can call into C++ code. This was written last year. Just now at WWDC 23, Apple announced C++ interoperability for Swift. But unfortunately, I didn't have that last year. So hence, I needed to drop down to Objective-C. So yeah, 4 topics that I'm going to take you through to get from nothing to a finished app, basically. First, we're going to talk a bit about static and dynamic libraries. I didn't know the difference between these, so I dove into it and I'm going to explain it. Then mergeable libraries, which is something Apple just introduced this WWDC. Multi-architecture frameworks using XC frameworks, and a bit about the Swift Package Manager, because the Swift Package Manager can actually do more than you might think. So, static and dynamic libraries. If you ever created a custom library in Xcode, you get these choices, framework or static library. And I didn't actually really know what that meant under the hood. So the framework option is what you would call a dynamic library, and the static libraries is the static library. And I'm going to start with those first. What is it? So static libraries, they've been around since the 70s on Unix. So you have your C file. If you're writing in C, then it goes through a C compiler, this CC thing. CC is an alias on your operating system, usually for your C compiler. So if you type that in on your Mac, then it will give you Clang, which is Apple's C compiler. And in this case, it just spits out a program. That's how it started. You have your executable. It's a binary, and it runs. What happens if you have multiple C files that you want to combine into one final program? So for that, object files became a thing. So notice how prog over there turns into prog.o, and the other.c turns into other.o. So an object file is basically a compiled file that contains your symbols, or your functions, essentially. And that can then, it's an intermediate product that can be combined into a final binary. And for that, the linker was introduced, which is called LD, a link editor. And it merges those two object files into your final program. And this happens the same way for Swift files. Swift files also get compiled by the Swift compiler, the object file comes out, and it gets combined by the linker. And we can demonstrate this real quick in Xcode. So I have my Hello World application here. I created a Swift UI app, and I added a little dynamic framework called My App Core. And when I go here in Xcode, let's see if I can zoom in, to the report navigator, every time you build or clean your project, something shows up here. So in this case, if I build, my build log shows up. You can see all the tasks that Xcode does under the hood, which is actually really useful in a lot of scenarios if you don't know, if you want to know what's going on. In my library, I have a file called math.swift, and it has this huge command here that shows what it kind of does. And what I care about here is the output of the compile phase for this Swift file. So here it outputs a math.o file. And when I go to my terminal, I'll magnify this, I can check what kind of file this is. And it says it's a Mag-O object. So Mag-O is the format that Apple, that macOS and iOS use for such binary files. That's because the research kernel that macOS was eventually based upon is called Mag. And using something called OTool, we can actually view the contents of this. Oh, excuse me. So basically it says, please dump this object for me and give me the text section. And the text section, that means basically the binary instructions in this case. It's a confusing name. It has some weird name here, as you can see. And this is what you call the mangled Swift name of the function. And underneath are the assembly instructions in ARM64 for that. And we can actually check what the actual name is by running swift demangle, putting the name in there. Let's see if I copy this. And it says myappcore.square which takes an int and returns an int. And that's exactly what's actually in here in my math function, math file. So yeah, that tells you for C and for Swift, either way it gets compiled, an object file comes out, and the linker merges that. We can see the linker also here in the end. So first all of my source files get compiled, and then the linker goes to work to link it together. So we have this model here. So we have lots of .o files that combine into a program. What if we get a library from a third party with a bunch of files that we want to merge in there? That's what started happening. The people were passing the .o files around, I think, and they wanted a better solution. So then we have a bunch of library functions. And there was a tool, an archiving tool called R, which they used to combine the object files into an archive. And the linker was adapted to read from that archive file directly. And that would then result in your final program. And that's basically it for static linking. The downside of this was that the final program that comes out keeps growing. All the code from the libraries gets merged into one binary. So then it was optimized because the linker knows actually what symbols are used, what functions are used for my program from the library, and can only copy over those functions from the object file. So then the final binary gets smaller again, and this is what's called in Xcode dead code stripping, dead code elimination. So if you have an iOS application, it depends on a static library. Apple always uses this symbol to refer to a static library. Then the linker goes to work, and the library gets merged into your app, and there's nothing else. Basically, the binaries are combined. Then came along dynamic libraries in the 90s. Programs were getting more complex, and it was becoming unpractical to merge everything into a single program. It would get too big. So what happened was we put those object files we did earlier into the linker, and we get a dylib out of there. That's what Apple calls a dynamic library. On other platforms like Linux, it's called a shared object file, or DSO. On Windows, it's called a DLL, a dynamic link library. What happens then when we produce our program like this, the linker knows what's available. It produces a program, but the functions that we use from the library, they get encoded into sort of like a promise. So it promises that at runtime the function is going to be there, and it's going to be patched in there, but it refers to the code in the dylib that is actually somewhere else on the disk. It's not included in the binary at all. So when we launch our program now, when we launch our program, a dynamic linker goes to work. It reads the dylib from the disk, and it patches in the code basically into the slots where those promises are. And if you ever had a problem when developing your iOS app where your app crashes on launch and it says unresolved reference, unresolved symbol, that's because the dynamic linker tries to resolve a function, but the library was missing, it wasn't there, wasn't shipped with your app or something. So for the dynamic library scenario, if you make an app with it, this is what it looks like. So your app depends on the library. Apple always uses the yellow toolbox for a dynamic library. And it gets shipped into your app bundle, your IPA file or your .app on macOS, shipped along to the consumer of your software. And as soon as you start up the app, the system loads the libraries. And this is nice because in case of system libraries like SwiftUI or UIKit, the virtual memory system can do its magic. So when an app launches and uses SwiftUI, if there is already a copy of the SwiftUI framework loaded into memory, the system can just reuse that. It doesn't need to make an extra copy in RAM. Then onto mergeable libraries. So this is a concept that was introduced by Apple this year at WWDC. And mergeable libraries, so the static and dynamic libraries, they both have their pros and cons, right? So the static libraries, with that case, if the library changes, you need to recompile your whole application to patch in the new functions. And for a dynamic library, less recompilation is needed. Depending on your use case, you select a static or dynamic library, and mergeable libraries kind of gives you the best of both worlds. So this was just introduced in the new version of Xcode, and when we have a mergeable library, marked it with a star like this, Xcode can basically choose at compile time if it merges that library into your app, or if it treats it as a dynamic library. So the three libraries here, my app core, my app UI, and my app utils, they are all mergeable. And Swift UI is not, because it's a system framework. So when I compile my app, these all go into my application, and it still depends on Swift UI as a dynamic library. So then this is my final app. And this is nice because the dynamic libraries, they introduce a launch cost, a launch overhead to your app. So if you launch your app, DYLD, the dynamic linker, needs to kick in, load all those libraries from disk into your app. And in this case, if it's merged in, it's faster because the app can load straight into memory from disk as one. So for mergeable libraries, they added some options to Xcode. There's the build mergeable library option if you have a library target, framework target. You can turn that on to enable support, and then in your app you turn on create merge binary like this, and Xcode will do the rest for you. I have not had the chance to play with this much in my own apps. As I said, the app that I did all this for was last year, so then this option wasn't available. But know that this is available now. One other scenario that Apple mentioned is if you have multiple mergeable libraries, another library depends on them, but it itself is not mergeable, then it will work like this. So the three dependents will just be merged into this library, myappLib, but because it itself is not marked as mergeable, then it will remain separate as a dynamic library. And these are, just as any dynamic library, distributable as an XC framework, which I will talk about in a minute. And again, the user of the library, so my app that I use it in, decides whether it's merged or not. Onto multi-architecture frameworks, aka the XC frameworks that I mentioned earlier. An XC framework is something introduced a couple of years ago by Apple. Leading up to the Apple Silicon transition, they actually introduced this because we have all these platforms. We have macOS, iOS, tvOS, watchOS, and multiple architectures. In case of the Mac, we had the architecture transition to ARM, and they they basically solved these problems of having lots of copies of the library for each platform and architecture by creating a container format, which is called XC framework. And a single XC framework that contains multiple copies of one static library or dynamic library, but for multiple architectures and platforms. And Apple uses the blue toolbox to refer to that. So we have these yellow platform-specific frameworks, and an XC framework merges them all into one container, which you can easily pass around as a dependency for your apps. And then Xcode will automatically select the right platform and the right CPU architecture that it needs to do the compiling that it does. It looks like this. So an XC framework is literally just a folder with an info.plist file in it. In this case, this is a static library, so you can see the .a file here, like we talked about earlier. And it has a little folder of headers, because it's a Objective-C library. You need to ship headers with it to know what's in there. In case of Swift, it ships a Swift interface file, which is sort of like a header file for Swift, but that's managed for you by Xcode. Dynamic library looks like this. Similarly, we have a folder here for iOS ARM64 and the simulator. We needed that for my project last year because I was still on an Intel Mac, but someone else was on an Apple Silicon Mac. On Intel Mac, you actually have an Intel simulator, so you need that binary. Oh, and this is actually the wrong screenshot, I think, that I put in here. This is also an A file. Sorry. So how to build one? If you have your Xcode project, so I made a project for this IFC++ library. We can specify our destinations. So I need it for iOS and for the simulator. And we need to pass these two options, most importantly. The skip install means that Xcode will include our build library into the archive. And the build library for distribution, it enables the right optimizations, I think, for the build. And it includes the metadata for the library that Xcode needs to consume later to use it. And then the second step is to convert that Xcode archive into our XC framework. We use this command for that. Xcode build create XC framework. And we just need to specify our archive path and the name of the framework that's inside, and then our output. And then as a result, we get a folder basically just like this one. That's all well and good. And how do you use it? Yeah, it's a question.
Yeah. My question is like...
Do we need a mic for the question, by the way?
So my question is, where did you put these commands? Like, did you put them in a make file or just a shell script, or how did you do it?
I made a shell script and I put it on a GitHub Actions workflow in my CI. So basically for the IFC++ library, I forked the library to my own GitHub, and I expanded it with an Xcode project and some CI configuration that uses these commands to build the framework, zip it up, and it uploads it as an artifact. Yeah, and in a minute I'm going to show you how I actually then use it in my project using the Swift Package Manager. So one way to use it, if you have an XC framework, is just drop it into your project. Back in the day we used to do that. We would check them in, check our framework in, drop it in there. And for an XC framework it works the same. You get again the blue toolbox, and Xcode decides which framework from the container it will use, depending if it's for iOS, macOS, and for which architecture. But the Swift Package Manager actually understands the XC frameworks as well. So Swift Package Manager is, of course, the package manager if you're developing for Apple platforms. We've had CocoaHeads and Carthage for a long time, and then Apple came out with SPM years ago. And it's what I would recommend to use for everything unless you can't. You can put code in your packages, resources, and binaries. So, of course, you can put source code in there, your Swift code. Resources as well, if you need to ship images or localized strings, that actually works in a Swift package. And binaries, which we'll talk about in a minute. Also, it's called the Swift Package Manager, but it supports actually 4 languages, the same 4 that Apple supports in Xcode. Swift, Objective-C, C, and C++. So you can totally make a Swift package that's written in C or in C++, as long as you do not mix Swift in there. You cannot mix Swift with any of the C family languages. You cannot mix them in the same target, if I'm correct. So if you have one package and you have multiple targets, and each target must be the same language. So then, to answer your question, I had my GitHub action create and compile my framework. Then it uploaded it as a GitHub release, and it gives it a URL where the Swift Package Manager can download it. So then in my project, I have my app, my Swift package, and it depends on those 2 libraries that I mentioned. We pass it a URL and a SHA-256 checksum, so that SPM can verify if it's not tampered with. And that's all we have to do, basically. Xcode and the Swift Package Manager will wire it up so that within the package I can import the headers or import the frameworks that I want. And will be included in the shipping app, of course. And that's how we ended up like this at the picture that I had all the way in the beginning. So my app, and it depends on the package, and the package depends on 2 libraries that I can harness all of the power of. That was really great. yeah, the source I used for this talk are these WWDC videos. If you want to dive in deeper, I can recommend watching those. And they go way deeper into how the linker works, into how Swift Package Manager works. And that's all I got for you. Are there any questions?
You said it's optional to choose if you want to make it a mergeable library and if you want to merge a library.
Yes.
But what are the reasons to not opt into that, or basically always do that?
So I watched the WWDC talk, but it also wasn't quite clear to me. Yeah, so when I created my new project in Xcode, I had to actually opt in to making my library mergeable, and also opt in to have Xcode automatically merge into my app. Yeah, I don't know why it's not the default to put it on automatic and yes, mergeable. Yeah, as far as I can tell, there are not really downsides. So your framework, it must be compiled with support for mergeable libraries in order to be mergeable, because Xcode will put extra metadata in there. So yeah, maybe it's not quite ready yet for some bigger apps, because I think apps like Booking.com or Uber, like huge apps with hundreds of dependencies, they will really benefit from this, because the dynamic linker needs to do way less work that way if all the libraries are merged in. Yeah, I don't really have a good answer for your question. Anyone else? Okay, thank you.
Well, thank you, Mathijs. presentation of the evening by Mathijs Kadijk, a Mac-tastic indie adventure. So please hands up for Mathijs and enjoy the presentation.
Thank you. Thank you, Bart, for the intro. So I'm Mathijs, and fall last year I was at a startup. I was CTO, and that startup didn't make it. We have been working on a meeting platform, where you met these little robots on a tropical island, and it was like going wild during the pandemic. But after the pandemic, everybody was sick of meeting online, etc. This was going down. We were at an all-time low. And in the end, the whole team got laid off, including myself. So, yeah, I was out of a job, and it brought me at the point that I was wondering, like, okay, what do I want to do now? What's my next gig? And I was thinking, okay, I can join another startup, maybe VC-backed startup, something like that. Could be nice. I could try my luck at the bigger corporate, maybe. I've never been at a bigger corporate. Could also be interesting. Or maybe go back to the agency world. I've worked at Q42, where we are right now, for quite some years, so could go back to that. And I wasn't really sure, so I decided to take a little time to think about it, chat with friends about what I was going to do. And one of those friends was Tom. He's standing over there. And he was also at the point where he was deciding what was next for him. So we were drinking a beer or two, and we started to chat about things that we really admired, like great iOS and Mac apps. We were talking about companies like Panic, you might know from Transmit. It's really a great app, a little team that's working on that. And that was something that really resonated with me. I was feeling like, okay, that would be really cool if you create with your own company, your own apps, you work on what you want to build, and really put back that craft in the apps that you really can see in the greatest iOS and Mac apps. So yeah, that was really something that I wanted to do, and I also really liked to do something that was not VC-backed, where you have to grow all the time, but do something sustainable. And also, when you work at an agency, it's pretty nice, but you're always working for a client, so you're working at the whims of what they want to do and what their company needs or what they find important. So being independent also was something that I really liked. So yeah, basically from drinking that beer together with Tom, yeah, that got my indie adventure started. And now we're here. We're now like a year later. Tom and I are running an indie company together. And this moment especially, yeah, it's quite monumental for us, and it's quite exciting and also a little bit scary because, yeah, we're at a point that dream of becoming and living from an app that we created could become reality. So that's pretty exciting and an interesting moment to tell a little bit about the journey. So it was quite fun, and then I hope I can share a little bit of the highlights. So we founded our company, and it's called Monstrict. And one of the first things that happened right after we decided on a name was that a lot of questions basically popped up, like, okay, what apps are we going to make? How is that going to make money? How do we avoid getting bankrupt in like the first month? That was also a very important thing. And also, how do we make sure that we actually work on the same goal? Like, we're two different persons. We have also other interests. We like to develop in Swift. That's a common thing. But yeah, we could have very different opinions about how to run an indie dev shop. So all those questions were popping up, and we decided to sit down and basically first talk through it and create a plan. Like, okay, how are we going to do this thing? So what I really liked about that we sat down and created the plan, and at the time I didn't realize this, but is that it really helps us to go super fast and not talk for day to day, talk a lot about What are we going to do? What is next? We just sit down and write code or do whatever we think is important that day, and we don't need a lot of communication. And when creating this talk, I realized this was something that I should have done earlier in my career, also at other places, and not only now. It's my own company. And a big part of that is how our planning is structured, basically. So we have our dream. Our dream is to be that indie company having maybe 4 apps that are making the money that we need to be self-sufficient. But that's a really big goal. I can't work on that day to day. I have no idea what I should do when I sit down behind my desk and go work on that. So we started to break it down, and we were thinking like, okay, but if we take the first year, so what's the goal for the first year? The goal for the first year is to not go bankrupt. That's a very important part of the goal. And the other thing is that we wanted to prove to ourselves that we can build an app that is really interesting to other people, that people are actually using. So not some app that we find fun and is super polished, and then we release it and nobody's using it, nobody's paying money for. So we don't have to be self-sufficient based on our app in the first year, but we do want to see that there are proof points that people are using it. So that really helped to break it down again into the first quarter. Okay, in the first 3 months, what do we want to do? Are we working on not going bankrupt and getting a client immediately, or doing some freelance work? Because that was what we decided, like being self-sufficient of our own apps is too risky. So let's do a little bit of client work, make some money, keep ourselves alive, and then also create time to work on our own apps. So the decision was, no, in the first quarter, let's first focus at least the first 1.5 months or so on building an app, because we were very afraid that we would turn into an agency. We were both coming from an agency, and taking the money from a freelance job is very quick and easy compared to building your own app. So we were really afraid that we would not get into building our own app. So we decided, first things first, build our own app, build momentum in doing things for yourself, and then find a freelance or consultancy gig to make money from. So that gave us a clear goal for the quarter. And we basically already got started by then doing day-to-day things, and then we realized, oh wait, we need to plan just the week. So every Friday we sit down for like an hour, and we say, okay, what are the important things for next week? What are we going to work on? Are there clients we have to call back, or are there important stuff or bugs that we absolutely need to fix? We list that, and that's all the planning that we do. So day to day, there's no stand-up or anything. We just sit down, and we know this is the goal for the week, this is the goal for the quarter, this is what we're going to work on this year, and this is the dream that we want to get to. And whatever needs to be done to get there, that's what we do. And that gives us a lot of speed, a lot more than I've seen in teams that I've worked in. It's always a lot of, oh, am I doing the right thing? Well, if you know what the goal is for every size of time increment, and you can decide for yourself, basically, especially if you're capable, intelligent people, like basically all of you here. So that worked really well. That was great. So Q1 was for our own app, work on that. Next to founding the company, by the way, that's also a lot of work. That was also something we did in the first quarter. Let's see. So with all the planning in place, we started, and then this tweet came along from Adam. He makes Screen Studio. He tweeted this: I'm looking for a badass Swift developer to write a binary CLI for screen recording on steroids. The spec is over here, Notion link. If you're not a super experienced developer, please do not DM me. It will 100% not end well and will waste each other's time. No agencies as well. DM me. So now that was obvious, Tom and me, right? I was actually very nervous to contact him based on all those superlatives and don't contact me when you're an agency. I was like, we're 2 people, so he's probably going to think we're an agency when he sees the company name, etc. But I did text on like, okay, this is a very interesting thing because it's a macOS thing to work on and not iOS, which we did a lot. It's a command line tool, which is very different from a lot of UI apps that you make where you pull something from the server, etc. Screen recording was very interesting to me. And the Screen Studio app is also a really great polished app, so it's really cool, and he was already getting traction. So that was super cool. So we DM'd him. It was a lot of back and forth in the first month of our company. And then we got the job, so plan failed. we already had our first gig before we even started on our own app. We were only busy founding the company, getting this client in, and then there was no work done on any of our own ideas. And I think if you're going to do planning and going for a goal, that's something you also have to keep in the back of your mind. Like, well, if your plan comes in contact with the real world, it immediately fails. Okay, so you have to adjust, and that's also okay. We do that still a lot. It's the third quarter now that we're in. 3 weeks in, we totally changed our quarter goals because it was super clear that we had to do something else that was way more effective to reach our dream in the end. So that's good, but the plan really helps also day to day. And I think this job we did for Adam was really interesting because it had a lot of impact on everything we did after. So what is Screen Studio? Screen Studio is a screen recorder. So you just record your screen as you would always do. And then after you did the recording, Screen Studio applies effects on it automatically. So it zooms in when you click somewhere. It moves with your mouse cursor automatically. Once it's zoomed in, it makes the mouse cursor bigger. It has all kinds of special curves for zooming and panning that feel really movie-like. You can also edit it yourself, but the real magic is that once you have done the recording, this is just really clicking those things, hitting export, and then you get the video like this. And it has become quite popular. Companies like Stripe and Figma have used it to do product videos that are in their help pages or in their marketing materials. So that's pretty cool product that he created. And he's just all by his own. Now he has 2 good friends who are helping with support, etc. But he's the sole developer of the app. And the app is in Electron. So that was one of the parts why he wasn't able to. He was also a front-ender from his previous job. So the front end is like awesome, and he did a lot of awesome back-end work to do the movie stuff. But a command line binary in Swift calling native APIs on macOS was a bridge too far for him. So that's what we created for him. Really a binary. His Electron app calls out to the binary and gives us a set of configuration options, what we need to record for him. Then we just kick off the recording until we get a signal from him, like, okay, now stop the recording, and then we wrap it all up. And we don't record one source, so it's not only screen recording. We also record system audio, microphone, webcam, mouse movements are recorded, keyboard input is recorded if you want that, and you can even choose to record multiple of those sources at the same time. So the main job of the recorder that we created is to keep all those things in sync and make sure the recording is perfectly aligned, so you don't have time shifts in everything, and also be performant enough to do this. Because Adam wanted it to be compatible with macOS 10.15, so we needed to be backwards compatible a little bit. And that was doable, but also quite a challenge because it also opened up a lot of different Mac hardware that we had to support. One of the things that made it really interesting, as I said, is that the command line thing has no UI at all. We can also not pop up any UI. The only thing that we can do is report errors back to Adam's Electron app, and then he can handle it. But that's also the end of the recording then. So that's it. So it's really confined, and we just need to handle everything, basically. If it is an error that we can recover from, we just have to do it. You also can't interrupt the user during a screen recording, because that's also the end of the screen recording then. The user's then totally confused. And that also made it really hard to troubleshoot issues for us because we don't have direct contact to the users. Users will contact Adam. We don't have any UI that we can pop up, so we can tell the user exactly things that are happening. There is no UI you can click through or see to debug things if the user sent a video or something. So that's why we decided very early on to invest a lot in logging in this scenario. And logging is pretty obvious. You can just start logging. But I think there were a few things that really helped us with Screen Studio. So there's some practical tips here. And the first tip is write logs and put them somewhere where you actually can recover them. Because I've done that a lot, and I realized in iOS apps, I was just like, oh, let's add a log, and that's handy for development. Sure, but if a user is going to call you and saying, yeah, but the app is not working, how do you pull those logs? How do you get those logs from the user to you so you can actually inspect them? So what we do is we write them to a file next to all the movie recordings, for example, and that's wrapped up in a Screen Studio package. So Adam often asks, can you send me the Screen Studio package of the failed recording? And then the log is also in there. So they automatically send the log over, and Adam then forwards us the log, and we can inspect what was happening. Also, log all context you would want to ask a user about. So we didn't do this perfectly in the beginning. And what happened was I got a log, and then I replied to Adam like, okay, yeah, I need to know what Mac this user had. What macOS version was he on? What devices was he using? Stuff like that. So at the start of a recording, we first log, okay, we are running on a device of this model. This is the OS version, this is the app version of Screen Studio, this is the app version of the binary. These are all the devices that we're going to record. This are all the configuration parameters that we've got, so that all the context is clear. And also, as soon as we start recording, we also log like, okay, this is the webcam that we're using. It's in this configuration mode, so that we know a lot about what's going on, and basically never want to go back to the user to ask what's happening. And one neat trick that I got somewhere from the internet, and I forgot where, is to wrap every action you do. So for example, we need to configure the webcam. And if we start configuring, we do a debug log, and we say, okay, we're now going to configure the webcam, and this is the configuration we're going to apply. And then once we've done that, do an info log statement where we say, we have now configured the webcam, and it is now in this state, and log the state of the webcam that's actually, it actually is in now. And that really helps, and the debug info works nice with OS log, for example, because debug logs are kept in memory, and after there are too many logs are dropped, but it depends a little bit on the framework you're using. But the point is really that if you do that before and after the action, if something goes wrong in between, or you think you have applied a certain configuration, you can see that you tried to set the webcam at a certain resolution, but it just refused to do that. And that's where the bug is. Because only logging it before or after often fails. Also, if it just throws an error in between, an exception is raised, then you don't know that you've started to configure the webcam, and that's where the error is. So this is one of the things that was really helpful when looking for issues and troubleshooting users. So I can really recommend to do this. It will add clutter to your code base, because everything will get 2 lines around it, especially in short functions, but it really helps. And of course, warn an error about issues that you encounter. I think that's quite a logical one. And if you want to get started with this in Swift, OS log is great, especially in the new Xcode version, where you have the new console. Then you have great filters on categories or other fields that you add in your logging. So OS log is great if you're doing an iOS app. For a console app that we did, we used Apple Swift log package. That was really convenient to just write it out, and we couldn't access the console anyway as a child process, etc. So for us, that was easier. Those are quite great choices if you want to look into into logging. So all the logging aside, one of the most important things Adam wanted to improve was screen capturing. And in recent macOS versions, Screen Capture Kit is introduced. That's introduced in macOS 12.3. And we rely on Screen Capture Kit to do a lot of the screen capturing in the recorder. And the neat thing is that it can also capture audio. And before Screen Capture Kit, you always needed to install some kind of kernel extension thing and to hijack the audio, etc. That was very inconvenient. Apple also makes that harder and harder with every macOS version to protect the system. But with Screen Capture Kit, you can just access it. You have to, that's perfectly allowed, and as long as the user allows the recording, then everything is good. And what's really cool is that you can not only record the whole screen, you can also choose to record one window, but you can also choose to record the whole screen and exclude a window. So for example, when you do a recording and you have like a little webcam in the corner as a preview to the user, you probably don't want to have that in the recording because you can just record the webcam feed separately. Then you can, with Screen Capture Kit, create a filter and you exclude the webcam preview from the recording and it's just not there. So that's really neat. You can also disable the cursor. That's also something that works. And a really neat feature is also that it only sends you frames when something changed. So if the screen is perfectly still, like it is now, then you will receive one frame of this image and then nothing else until something changed on the screen, and then it will deliver the new frame to you. So that really helps in being efficient if you do a streaming thing, or just doing less work if you do image manipulation, for example, on the stream. So one of the things Screen Capture Kit doesn't do by itself is recording to disk. Screen Capture Kit is really created and pitched all the time as something to stream video over the network. But I think a pretty great use case is to record to disk. But we had to figure it out ourselves. So we do have a blog post about this if you want to try it yourself. But I think what's really interesting is that what Screen Capture Kit needs to record to disk is very much the same as recording a webcam to disk, for example. They're all really the same concepts over and over. So what you need if you want to do screen capturing with Screen Capture Kit is create a Screen Capture Kit stream. You can create an object and set filters on it. And then you tell the Screen Capture Kit stream to start capturing. And it will call a delegate method. And the delegate method will get a CM sample buffer. And a CM sample buffer is an object that's as old as macOS is, I think. And it contains data, so the video itself is in there, so it can be really big. And timestamps and metadata about that certain frame, so the time the frame is, the duration of the frame, stuff like that. It can also contain audio as the same structure. And the neat thing is webcams will also deliver CM sample buffers, for example, and a microphone will also deliver CM sample buffers. So as soon as you have configured something that does capturing or recording, you get that sample buffer, and from there you can put it in the same code path you use for other stuff also. And you can then pass it on to an AV asset writer. So AV Foundation has this class, and it's optimized to write video files and audio files to disk. And this also does all the encoding stuff for you. So the sample buffers often are uncompressed data when you work with capture devices. So the webcam just gives you the raw image that it captures. A Screen Capture Kit stream just gives you the whatever is on the screen, uncompressed. And the AV asset writer knows how to compress it, and it's all hardware accelerated. So that's pretty neat. And it then can output it to a file. You can also fiddle with settings and do other compressions, etc. That can become quite complex, but the basic is pretty neat. And so the bottom side here of the AV asset writer is also something that you can customize. If you don't want to write out to a file, but want to do a live preview window, for example, like with a webcam, or have a live preview of what you're streaming to people on the Zoom meeting, Then you can also put the CM sample buffer into a view that supports that. Apple has a special layer that supports displaying sample buffers. And then you have a live preview. And that also works for all those sources. So you can switch out the top thing or the bottom thing, and they all work with CM sample buffers all the time. So if you're going into capturing, learn about CM sample buffer, because that's a very valuable thing to know about. And if you want to play around with ScreenCapture and recording, look at our blog, because there's a ready-to-go sample to fiddle around with. So with all this recording experience, we started to work on some of our own ideas. This icon, for example, is from Clean Presenter. That's one of the first apps that we released. With Clean Presenter, you can take over an external screen and only show one app. And it also uses ScreenCapture to capture that one app and then display it on another place. It's basically streaming, but then on your local Mac. And what was also interesting is that we got more and more clients who then knew, hey, you know stuff about macOS capturing, so maybe you can help us out with our app, with a streaming app or another kind of recording app. So that was pretty fun. So we dig deeper and deeper in weird issues and APIs. And how did they find us? Well, through our blog. So every time we encountered an issue that wasn't easy to solve, we basically wrote a blog about it, just like the how do you write a file to disk with ScreenCapture that wasn't obvious. People started to finding those blogs, and that was really fun and nice, not only because it got us clients, that's nice too, of course, but we also every now and then get an email from a random person on the internet working on a random app that's saying, whoa, you've solved my problem. I was looking for this and I couldn't find it on Stack Overflow, but I stumbled upon your blog, and I found it was really nice, and we had some fun conversations over the email about, oh, how did you solve this weird issue, or did you get a workaround from Apple because you're at the big company? We were asking them, like, you're at the big company, so maybe Apple is helping you, and do you have more info? So that's really fun. That's a really fun thing to do. And it really helps to have a little bit of exposure and interesting conversations with people. But we don't only blog about issues. We also report them to Apple in the feedback assistant. You might know the feedback assistant. And I think one of the, so when in like the more than 10 years I do Apple development, I think I created 3 radars of feedbacks or so. Now, well, what are we? 9 months in working at our company, I created more, together with Tom, than fit on the screen. And what really changed, I think, is that our mindset is now, if we encounter a bug, that is a bug in Apple's system, once we figured out what it is and have a workaround or something, we just stop working for a moment and put in feedback with Apple. Because if you do it at that moment, right then, you know all the context you need. It's fresh in your mind, and it's pretty easy to type it in. So you can at least shoot in feedback and tell them, please fix this, because this is a weird bug. And since we also now try to blog about it, once we encounter a thing, it's also like 50% of the work that needs to go into the blog. And if we need to do a sample project, that's a little bit more work, but then it's also shared between the blog and the feedback, and it's a lot more fun to then create a sample project instead of only submitting it to Apple and not knowing if they are going to do anything about it. So that's a pretty interesting thing, and I think it's also something we all can do. Like, okay, if you encounter something and you figured it out, submit it feedback to Apple. They're always asking about it. Please do this. And I've tried myself before. If you do it like, no, I've figured out how to work this, but I'm first now continuing on this project, and then the next day you try to submit the feedback, and then it's already so much more work that you're just not going to do it. So that's my advice. Just stop working there, take like 30 minutes and write out the feedback and submit it to them. At least that's then a vote for like, please fix this bug. So there's another thing that we do if we have a filed a feedback for an issue that we think is or should be better, or we have a very awkward workaround or something, or sometimes we don't even have a workaround, we're just stuck. We contact Apple developer support. You have 2 free tickets on every paid Apple account to contact Apple and ask them a question on the code level. And I think I've never ever used that while I was working here at Q42, maybe twice or something in my whole career here. But it's really a steal, and you can even purchase extra tickets for like $50 or so. That's nothing compared to your hourly rate all year. So I also would really encourage to do this, because what we do is submit the issue basically and say, okay, we have this issue, here's the feedback, we already filed the feedback, so don't ask us to file the feedback, it's already done. You can look into this, and can you find us a workaround for this? Can you confirm it is an issue, and can you find us a workaround? And that often, sometimes we just get to confirm like, yeah, it's an issue, we don't have a workaround, we're very sorry. But at least then you know you can stop looking for a workaround because it isn't there. And sometimes you get some person in DTS that's like really dedicated and actually contacts a team, asks a developer like, okay, what can we do here? And they come back with a workaround that you couldn't think of yourself, or they can confirm like, yeah, if you call it in like the other way around, then I can't officially confirm that it will work, but it probably will work. So just try it, and then you have an interesting workaround to get around things. So that really helped us, and it's also something, if you already have like a DTS or a feedback submitted, it's really easy to also submit like a DTS, like, okay, it's the same thing copied over, and then just ask, can you confirm this is an issue, and do you have a workaround? So that's also a really interesting thing to do, and I think it's really valuable to see what you get there. And one thing they also can do is walk over to the team that's responsible for fixing that bug. So I have a DTS engineer that told me like, okay, yeah, I've asked the team to look into that issue to see if they can resolve it, and then you never hear anything again from Apple. But at a future release, and suddenly it's fixed. It's like, okay, this might have contributed a little bit to getting that fix there. And the last thing that's really fun to do and really valuable also is if you have all those feedbacks, it's basically an archive of everything you bumped into through the year. So once WWDC hit, we attended a lot of labs that were relevant for all the feedback tickets that we submitted. And then sometimes you get a DTS engineer that's responsible for that. So I had the case where I just got the DTS engineer that actually answered my ticket already and told me, I already have looked into it, I don't have anything else to say about the ticket. But Tom actually got in touch with the Screen Capture Kit team, for example, the actual engineers that work on Screen Capture Kit. And that's super valuable. Then you just have a chat about the issues that you bumped into, maybe the feature requests that you send in, and you really can give a little bit of insight that you else can't get. So yeah, it's really fun to do, and it's really valuable. And I don't think, I think I've attended a few labs with a few random questions that I could come up with during the WWDC before, but now it was like we had this long list that we could just submit and get like super valuable information from them. So that's also something I really can advise to do. It's a really easy way to maintain that list. So there was a lot of fun working on a lot of capturing stuff and encountering a lot of bugs, reporting them, etc. But working on so much capturing things also gave us a lot of capturing ideas to work on. We already worked on a Clean Presenter, but at some moment Tom said, okay, what we really should do is finally create this app that mirrors your iPhone, because that's always something we were struggling with QuickTime, etc. So our new app idea was Bezel, as over here, this is the app icon. And Bezel is an app where you can plug in your iPhone to your Mac with the cable, and it just appears on your Mac. And it was something that we thought, well, we have all the knowledge here. We know how stuff works. We already did screen capturing of the devices for other work. So why not create the best and simplest mirroring app that we can? And it was pretty fun to do because we did like the smallest prototype. So maybe you have heard of Jordi Bryan. He has a 2-2-2 method where he takes 2 hours to prototype something really quickly and then 2 days to make it a little bit better and share it with some friends. So basically we took like a day, threw together a prototype, put a tweet out, and immediately there was like reaction. People were asking, "Whoa, what app is this? I want to try this app. Where can I get it?" I was like, "There's nothing more than a video and a few ugly hacks in Xcode." So we put a Google form below the tweet and said, "Okay, give your email address if you want to be kept up to date." So that was pretty cool, and now we've developed the app further. So I can give a little demo of what we've created. Let me switch the screen mirroring mode. So if I take out my iPhone, plug it in, then it shows up. And now you see my home screen with my kid and my wife on there. So that's basically it. That's the app. You just plug in your iPhone and then it's mirrored. So it's perfect for demo. And it was really something we like to create. Because every time I gave a demo at Q42, I was always fiddling around with QuickTime. Then it was this square thing. I had clients ask me, am I looking at the iPad or at the iPhone app? I'm not sure. It's just a square, so not sure what I'm looking at. If you rotate the phone, it looks awkward. So those are things we all fixed. And I think that's one of the things that's really nice about building your own software, and especially also for a use case that you really know really well, is that you know what you want to fix and want to make great. So one of the things we also invested in is this little wizard. It's really awkward when you plug in a phone for the first time. I don't know if you've done that. Try to mirror a new iPhone with QuickTime during a demo where you're under stress. Like, okay, it has to work now, and then it doesn't work. That's because you need to do a lot of steps and do them correctly. So we really try to help the user. So we say, okay, connect and unlock an iPhone. So I pulled this iPhone from the device wall over here at Q42. And it has never been connected to my Mac. So once I attach the phone, first, my Mac is an Apple Silicon Mac, so it's not allowing me to connect to any USB device without confirming me that it's okay. So that's also what Basil is telling me now, like, okay, click that allow button. Then it's confirming that it's working. So that's great. Now I have to tap trust on my iPhone, so there is a trust button now on the iPhone. So I'll tap that, put in the passcode, and it confirms, okay, you've did that. And now I have to reconnect the iPhone. This is the most awkward part, and QuickTime is not helping you with that. So I was also like, okay, I've trusted, so why isn't it working? So we also try to help you there. So pull the cable out, put it back in, and saying, okay, there you go. And this is also an extra pop-up that we should help you with. And now it's here. So now it's mirroring. Oh, let me see if I can enlarge the thing. So now it's working. So that's also something we invested in, and it was pretty fun to work on because it's a lot of different APIs that are working together. So it's AV Foundation that's basically doing webcams all the time. That's telling us what the state of the camera is, combined with some private APIs from Apple to know more about the device and what state it's in. So that was really fun to create. And one of the features of Bezel is also that it detected that this is a white iPhone, so it's also showing the white bezel around it. But you can also switch that, so if I want the space gray version, I can just switch over to the other bezel. So this is one of the apps we're working on right now, and we had quite a beta group that was giving us feedback and on what to improve. So that was really fun. really enthusiastic users already. And next week is the moment that we go live with Bazel. So I'm really curious what it will do, what kind of traction it will get, and whether it will help us to reach our dream of becoming sustainable from our own apps instead of client work. So I can tell you right now, next week I will know more. And I hope to give an update in, let's say, about a year or so on where we're then with what apps we're developing at that moment. So thank you for your time. Are there still any questions or?
In order to be a sustainable business, you need to make some money. How is this app gonna bring in the money?
Yeah, so we're going to charge money for it. And what we're going to do is you can download the app for free, and there will be a little watermark on the phone, and it's a one-time purchase that you can do. So on our website, you can buy it for a one-time purchase, and then you unlock the phone or remove the watermark.
Other questions? No other questions?
Are there any plans to get Bazel working with the Apple TV? Because that's wireless data streams.
So we have a lot of ideas and things we want to implement. I do think wireless will be something that we will implement at some point at time, because also a lot of people are asking for that just when using it with the Mac. And once we go wireless, it is really interesting to also be on the Apple TV, etc. So yes, absolutely a dream. I really want to be there, but I think we first have to prove that this concept is working at all and is like working and people are actually using it.
A follow-up question. What I actually meant is connecting or like displaying the Apple TV within Bazel.
Ah, all right. Yeah. So that would also be an awesome thing to do. So I really would love to support other devices like Apple TV, but also Apple Watch, for example. So if you work on an Apple TV or an Apple Watch app, then it would also be really neat to be able to display the actual thing and share that. So yeah, that's something that I really would want to do. But first things first, and that's just completing this iPhone version wired on the Mac. Making that really good and adding some features there.
So for supporting other devices, do you already have clues that it is possible, or is this just a hope and you haven't actually investigated yet?
No, I think for a lot of devices it's possible to create something like that. So especially to show that device on your Mac. So for Apple Watch, we have some ideas and directions that work, where I've fiddled around a little bit with what we can do. And on other platforms, we also have some ideas how we can do that. So I'm pretty certain that we can do that, yeah.
Nice.
You're probably going to show the web page with the link to get Bazel, right?
Yeah, that was my other slide.
Okay, no,
So thanks for remembering me about it.
Any other questions?
Thank you very much for your great presentation. I was just wondering, how long have you been busy, the two of you, on this? Because maybe you said in the beginning, but
On the app?
No, when did you start with
So the company-
non-strict, and then this whole journey, how long has it been?
So the company started in January, and December was when we got Adam as a client. So that's the point where we started. So 9-10 months in now. Yeah. Made a love baby. Yeah. Our app is the love baby. Yeah.
Other questions? Then
Right.
I would
Thank
like
you.
to thank you, Mathijs, for your great presentation, and all the best with the launch next week.
Thank you.
So hope to see you back in a few months with a surprise story. But you might be on the Bahamas. Who knows?
Who knows?
Uh,
I can do a remote presentation. That's no problem at
No
all.
problem. Well, you can present the screen, right? So that's
Exactly.
no problem.
Yeah.
So thank you for your presentation, and also Mathijs for the other one, of course, and Q42 for hosting us. And please feel free to ask questions after the television or recording has been turned off. And then I hope to see you next time at NOS in Hilversum. Thank you.